Imagine asking an AI assistant to organize your files, and it rapidly starts deleting archives, emailing contacts, and executing financial transfers on its own. Autonomous systems executing unauthorized actions on our behalf is a very real, growing threat. To understand why this happens, we have to look at how software permissions usually work. In traditional IT consent, we give apps permission through a simple checkbox. It's a binary, one-time agreement. You click Accept, and you provide the system with broad, persistent access that stays open indefinitely. That model breaks down with modern AI agents. Agents don't just generate text or wait for direct input. They operate autonomously in the background, reasoning through problems and actively executing tasks. Granting perpetual, unchecked access to software that can think and act independently creates a catastrophic cybersecurity vulnerability. AI agents operate non-deterministically. That means their behavior isn't fixed. If an agent encounters new information or a shifting environment, it changes its approach and makes different decisions on the fly. This creates scope creep. The original, narrow permission becomes obsolete as the agent continuously branches out to solve a problem. Going off script, it might accidentally dig into highly restricted folders or pull sensitive personal data it was never supposed to see. The old click-wrap agreements we're used to have no dynamic fail-safes built in. There is nothing to detect or block the AI when its logic path unexpectedly pivots. Because AI is inherently unpredictable, securing our data requires moving away from static approvals and toward a system that tracks the agent's logic in real time. We need a living contract between humans and machines. This is called agentic consent. It's an ongoing agreement grounded in human intent rather than a single approval. First, this architecture requires dynamic, context-aware permissions. An AI's boundaries must construct and deconstruct in real time, matching the precise scope of whatever task it happens to be performing right now. Second, authority must be time-restrained. Permissions are granted exclusively for the exact duration of a single transaction. The moment that specific task ends, the access expires. Third, the system must enforce cryptographic identity. By tracking the exact digital identity of an agent and verifying every action it attempts, we can actually trust what is happening in a dynamic environment. By bringing together shifting contexts, strict time limits, and cryptographic tracking, we turn abstract trust into a rigorous, measurable security architecture. This architecture relies on granular policy control. Instead of broad access, we enforce hyper-specific restrictions. You might let an agent read your inbox, but explicitly block its ability to send or delete messages. But eventually, an agent will hit a friction point. It will encounter highly sensitive financial records, or a scenario where no predefined governance rule exists. When that happens, the system initiates just-in-time prompting. The agent pauses its autonomous execution entirely and asks the user for explicit permission to proceed. Your answer resolves the immediate pause, and the governance system uses your decision to automatically write a new policy to handle similar encounters in the future. Just-in-time prompting ensures that agents can never navigate high-risk zones blindly, cementing the human as the ultimate arbiter of action. Managing this active trust layer requires robust human-in-the-loop oversight systems, allowing organizations to continuously monitor multiple agents at once. This aligns with strict compliance requirements like transparency. Users must always have real-time visibility into what consent is currently active and exactly where their data is moving. Then there is revocability. Users must possess a total override, an emergency mechanism to instantly sever an agent's access across the board without delay. Finally, personalization allows you to draw permanent hard lines. You can indefinitely blacklist specific private domains or sensitive folders, preventing an AI from ever touching them. Constant transparency and instant revocability serve as the final, non-negotiable fail-safes against runaway autonomous systems. To move from small experiments to large-scale enterprise deployment, organizations need more than hope. They need the specific audit trails and control mechanisms provided by agentic consent to stay compliant with global privacy laws. It all comes down to a core philosophy. These systems are designed to ensure agents act collaboratively with us, rather than independently instead of us. The rapid expansion of artificial intelligence capabilities can only scale safely because we maintain absolute authority over the boundaries of trust. AI autonomy is a powerful tool, but it only works when humans remain firmly in control. If you found this breakdown helpful, be sure to subscribe for more deep dives into the mechanics of AI.